Hey friends, how's it going? Rosendo from MLH here. I'm really excited to be here. Welcome to Global Hack Week season launch. I know it's been a long time coming, and I know everyone here is super excited to be joining us for this week of festivities and learning. So I see that y'all are letting me know where you're joining me from. Skull from Rajasthan, India. Welcome. Everyone else in the chat, welcome. Really excited to have y'all here. Yes, hello, hello. Um, oh, we have other folks from India joining us as well. We have a great workshop in store for you today. We're going to be learning about Elastic, Elasticsearch, the Elastic Stack, and we're going to be joined by a developer advocate from Elastic by the name of Priscilla Parody. So we're really excited to have this opportunity to learn about a really interesting technology. Just remember, y'all, if you have any questions throughout the workshop, feel free to drop them in the comments. I'll be making sure to go through everything and ensure that all of your questions get answered. And yeah, I mean, honestly, with that being said, really excited to be here. I'm just looking at the chat and seeing we got folks from Toronto, from Colorado, all over the world, more folks from India coming in. So really awesome, really great to see that. Yeah, without any further ado, let me go ahead and bring Priscilla onto the stream and give her a warm round of applause, y'all.
Hello, everyone. Thanks for joining and thanks for the opportunity, Rosendo. It's really great and to be here with all of you, sharing a little bit about Elastic, but also about vector search. Before we start with it, I would like to introduce myself a little bit. I am a developer advocate, as mentioned at Elastic. As a developer advocate, my role is mainly to be the bridge between the company and the users. So because of it, feel free to let me know if you have a question, if you want to know more about some of our solutions. This is my LinkedIn profile. Probably QR code is not like the smartest decision for a screen, but anyways, you can it's my first name and last name, Priscilla Parody. You can just find me on LinkedIn and you can connect there, send me a message with your questions. I would be happy to help you all with it. And this is my email address. Also, feel free to send me a note. During the presentation, I'll try to look down a bit some of the times to read the chat. So feel free to put your questions there too. So if I'm looking down, I'm probably trying to read it all and follow it. But just let know if I skip something, I can just answer it during the presentation. So you don't need to wait until the end. Just feel free to let me know, and it won't be a problem for me to just stop and answer. Otherwise, after it all, I have like a time for us to talk, and you can ask your questions. And if you have something else that you'd like to share, a project, or anyways, just feel free to also use the time. We'll have like a time specifically for this. And yeah, let's eat Mary. Let me prepare the script here, and then let's start with the presentation. So as mentioned, today we are going to talk about unstructured data, so exploring vector search and NLP in Elasticsearch. This is the agenda. As you can see, there is a lot for us to go through. So that's why questions are important. I will keep going and keep sharing. Just let me know. Well, we start about talking about Elasticsearch, the Elastic Stack. And then I have a question here, just to know a bit more like about you, if you're using to Elastic, if you're using to Elasticsearch. So is some of you working with it right now, like knows what Elastic is, Elastic Stack? Are these terms familiar somehow or not? Heard a bit, familiar, new to this? Cool. Beginner for Elastic. Okay, great. And then let me keep asking then, because usually when people say they're familiar, I just like stop right now and keep going. So let me ask you another question. Like, are you using to NoSQL, or is NoSQL something completely new for you all? Like, NoSQL is fine. Database, know what it is. Okay, just for me, like to know if okay, something about NoSQL. Yeah, like MongoDB. Yeah. Perfect. Okay, NoSQL for must be okay, perfect. So all right, then I know like the level of details that I will share with all of you before the presentation, before getting started. So, but yes, continuing here, we'll talk about after introducing Elastic, we'll talk about unstructured data and what is vector search. And now that I'm talking about vector search, I get a question. Are you working with vector search? Do you know what it is? How familiar are you with this term, like vectors, um, dense vectors? First time hearing about it? Cool. We'll introduce it all. I think it'll make sense right now. Yeah, perfect. Someone asked about NLP here. So I will also, I'll talk about semantic search, which comes to the vector question too, lexical search and hybrid retrieval. And I'll also talk about, and then this is the question, NLP. So text embedding and NLP models. I'm not going that deep into AI, generative AI, how it works. This part I'm just skipping, but when I talk about NLP, mainly it is like the intersection between linguistics and deep learning. And deep learning is a subset from AI. So at times someone talks about AI, it's mainly ML, and ML has a subset, deep learning, and deep learning mainly is when it comes to NLP, it's an application of it. So I'm not like introducing these terms here because of the time, like how it works and things like that. But mainly this is the concept. So when you read it, it's about AI and AI plus linguistics. Let's go this way. Perfect. There is a good definition here. Oh yeah. AI and ML. Yeah, exactly. Deep learning is a type of ML. Yeah, that's it. Good definition. And then we'll talk about image similarity, search, and the data flow of it all. Yeah. Actually, when we talk about deep learning here, like deep learning is a subset of machine learning, and machine learning is a subset of artificial intelligence. Artificial intelligence is more like a concept of it. I have like a entire presentation on like the difference because of the time I'm not like going that deep presentation, but yeah, let's go this way. It's AI. So let's start here. Today we live in an always on world. From the time we wake up to the time we go to bed, basically everything you do, and most of it, it's data. And it's data being generated, data being collected all the time. Even if we don't pay attention, oh, okay, I don't use a cell phone, I don't use a laptop, anyway, I don't have it all. Either way, you are walking on street and there are cameras all over around. So things are happening, even if you don't want to. Data like weather being tracked and everything about it. So data is being generated either way. Data is being collected. Your friends, people you like, people you don't like that much because you just muted them on social media or you unfollowed them somewhere. You're going to a place, the name of this place, if you like this place, if you don't like this place, your bank, your transactions, how much money you have right now invested or not, your emails, kind of like everything. And when we think about like virtual reality and all of these features, it's like more and more. So everything is, if it's not connected, it's getting connected. I can't say the name of the app right now, like Siri, Alexa. I can't say it that loud, otherwise they'll talk to me. But it's kind of like even everywhere at home too. So we are fully connected. And this is really good because it means that we have data, and data is about insights. It's about new possibilities. It's something that if we have, we can do something with it. But with it, of course, comes a real challenge, which is fine, I have it all, but how to put everything to work and really start using it. What we need is search, and Elastic is a search company. Usually when I talk about search company and when I say that Elastic is a search company, people come up with this search box, which is true. This is one use case. But I want you to think here that actually it goes beyond the search box. Let's think of Uber, for example. When we have like this interaction with the app, so Uber, for those who don't know or you're not familiar with it, it's mainly a way for you to order a driver and go from a place to another place. So what you do is you insert the address or the name of the place that you want to go, and then you just wait for the driver, and then you go to the place that you want to go. So basically, if you think of like search as just a search box and a text field, first thing you will think about is, well, the Uber search experience is mainly when I type the address and that's it. But actually, it's not, or not that, or not just it. If you think of the Uber core when it comes to search, it's actually the GPS coordinates. Think of like how many GPS coordinates per second or millisecond they have every time. And it needs to work, and it needs to work really, really well. Otherwise, it won't perform, and you probably use another app or something else. So this needs to work, and this is also something that is a search experience, even not being exactly a text. Well, Tinder is another example. So Tinder is a match app for like I like to say that it's a human database. So mainly you're looking for the person that you want to hang out with, that you want to know a bit more about in ways, and you say yes or no. So right or left, and then you can navigate and choose the right person in ways. So this is another search experience because in the end, what you're doing here is you're filtering, and filtering is all about data, all about database. So again, you're doing this when it comes to Tinder in a completely different experience. Actually, you don't have even like a search box or something. Search is a constant, is a foundation. It's basically everywhere. So I'm talking about Tinder, Uber, and all of these apps and examples, but think about the back end of it. Think about your infrastructure, your metrics, your logs, and everything that happens in the background that you don't really see as a front end of apps. So everything is also there, it's also happening and is data and needs to be not just track it and monitor it, but actually you need to do something with it. You need to search to do something with it. So let's meet the Elastic Stack then and how it works. For those who were or are familiar with the term the ELK, ELK is basically the way we refer to Elasticsearch some of the times, or at least most of the people. So ELK is another term that I'll probably use as part of the presentation here. So this is the Elastic Stack. It's a way for you to insert data, structure and unstructured. I highlighted unstructured because for this presentation, we are focusing on unstructured, but it's a way to insert data, store, search, analyze, and to get insights from there. And to support it, of course, as expected, you have the core of it, which is the place where you store your data, Elasticsearch. So this is our data store, our search and analytics engine. So your data will be here. This is not a relational database. That's why I asked it about NoSQL, SQL, if you're familiar or not. So basically your data will be stored as JSON documents. And this is completely RESTful. So this is the core of it. And to support the usage of Elasticsearch, we have some other tools. One of them is Kibana. So Kibana is basically the interface to explore Elasticsearch data. So as long as your data is stored into Elasticsearch, you can just explore, you can create dashboards, you can create canvas, you can export PDFs, and even insert data. Like there is a DevTools tab where you can just insert data, more data into Elasticsearch through this interface. So there are a lot of possibilities here if you prefer if to something else than the command line, for example, and here goes. So Kibana is a way to go. And of course, besides this, you need to put data into Elasticsearch and get it from Elasticsearch. So we have a lot of integrations, a way for you to connect and collect data from this. I like to say it's kind of like any source, any data, basically everything. Because even if it's not a format or something, we have ways to create pipelines. We have ways to format data, and here it goes. So there's a list, more than 200 possibilities for you to put data into Elasticsearch and to get data from there. And after it all, the code of Elasticsearch is open sourced, so you can read it, you can understand how we made it, you can understand the progress of it. There are a bunch of issues, GitHub issues open, bugs reported, everything. So you can interact with the community, you can ask questions, etc. So it's really good for you to learn a bit more also about the tools, about everything we create, about everything that's out there. And finally, you can get insights by having your data there too. I'm trying to pay attention to the chat sometimes, but yeah, it's no SQL. Yeah, it's not relational. Yeah, not relational. Yeah, you can work with API. Yeah, it's RESTful. JSON, exactly. It will be JSON. Yeah, JSON documents, exactly. So why search and extract insights from unstructured data? So going back to the topic here today, I said we're going to focus it on unstructured data. So why are we focusing on unstructured data, and why do we need to search and extract insights from unstructured data? Let me put it in numbers here. 80 to 90% of data is unstructured data. So if you think of like text, video, audio, and here goes social media posts, which are from of like image plus text, and every single type of this, not well structured or in tables or with columns, and this spreadsheet like formatted data is unstructured. So it's a lot. It's a lot, and it's out there. Cameras, as I said, like everything basically. Besides this data that is well structured, like SQL mainly, then very like columns, etc. It's unstructured. So it's most of it. But the point is, and the problem here is, the challenge, better saying, is that less than 20% of organizations reported being able to analyze and take advantage of this data. So this is something here for us to explore, because if we have almost all of it as unstructured data, and we are doing something, we are using less than 20%, so see the gap here for us to take advantage, to see what else we are able to do and to utilize this data that we are storing and basically not using it. So that's why we'll talk about vector search, and you learn what it is in a bit. Vector search improves search, facilitating the extraction of insights from unstructured data. What is vector search then? Finally, vector search, I'll read the sentence, but then I'll explain. Vector search is a technique to search for similar vector representations of data in the embedding space, summarizing it and explaining what it is. You have a document, you generate a vector representation, an embed. There are many different ways to generate it. And then you perform what we call a K&N search, a K nearest neighbor search. This is what you do in this, and this is like the embedding space where it lives. So how does it work? Here, the embeddings represent data. So here is one-dimensional space. We have like something that goes from realistic to cartoon. So this is one-dimensional space vector where we have the elk, the realistic elk, and the cartoon elk. So the cartoon, this student elk, and the realistic one, we have like two streams of it, two different aspects of it. So we have one dimension. We can keep adding dimensions here. So to the same one, we can add also other characteristics. One is mammal, another is bird. So we have an owl here. We have the cartoon owl, and we have the realistic owl too. And then we have like more aspects of it. We can keep adding, actually, we can allow more and more and more dimensions with more characteristics of this data. So in the embedding space, which is where it lives, similar data are grouped together. So as you can see here, you have more types of cartoon elks, and you have more types of birds, and here goes, all of them living close to each other. So for example, here, if I take one of these cartoons, the elk cartoon, and put wings here, well, it suddenly started flying. So it's almost a bird, or going to a bird too. So this is how it looks like. If it's like about, I don't know, countries, and then you can put like culture, you can put food, you can put anyways. So this is how it's the embedding space looks like, the characteristics and the dimensionality to express the characteristics of the data. So the vector search finds similar objects as those close to the query. So assuming we have this student elk here as a query, this query is also vectorized. So in the embedding space, this query, as you saw on the other slide, this is right here. And then when it comes to the relevance, of course, when there is a search, you have the relevance of the results, because your idea is to find the match, the perfect match, or something very, very close to perfect. So the relevance here is, again, as a search experience, measured by how right it is, how close it is. In this case of the embedding displays, is how close the query is from the other results that are similar to this. So that's why you have like as the first, the other elk, the cartoon elk, and then second, another cartoon elk. And here it goes based on the distance. So if it is close, it's relevant. If it is really far from the query, then it's not that relevant. But what's the point of it? Probably you're asking yourself, what does vector search allow? I get it, I get the concept, I understand dimensionalities, the characteristics of it, I understand all of these embeddings anyways, but what's the point of it? What does it allow? It allows semantic search, for example. So if you go and think of like traditional text match, even Elasticsearch, we have BM25 as a lexical search. So specifically, like when you're using Elasticsearch and you're using BM25, what it does is it measures relevance based on frequency and rarity of terms. So we have a query, and you are looking for a perfect match to this query in order to find the relevant documents. In the end, when it comes to search experience, your intention is always to find the top relevant document, like the one that makes sense to your user, or the ones that makes the most sense to your user. This is the output, and this is what you're looking for. And when you are using a traditional text match, this is basically what you're doing. You have all of the sentence, you have the tokens, the parts of the sentence, and then you use it to return for you what makes sense, what is more relevant considering it all. So it will basically look for perfect match. Of course, there are other things you can do here, like you accepting fuzziness, for example, to tolerate some mistakes, and here it goes. But basically, the way it's going to rank in your data, it will be using and it will be looking for the terms itself, if there are lots of them, or compared also to the documents. So if it's rare or if it's not rare, and if it's appearing more often or not. But looking for perfect match. So if the word is not there, it won't come up because it's basically not there. With semantic search, on the other hand, you can go beyond text match, allowing what we call a context-aware representation of text, taking into account semantic knowledge, intent, ambiguity, etc. So to understand it, basically, this example, read it with me. Probably you already read it, but read it with me, or try to read it with me. The man went to the, and then you put a mask. Well, the man might be going anywhere. I don't know yet, too. But then I keep reading it. He bought a, I don't know what, of milk. This is basically the way he learns, literally. So that makes sense. He bought a milk. If he bought a milk, it's probably from a store. And what milk? Like a gallon of milk. Then it starts to make sense. What I want to say here is context is really important. And there are words that, even not knowing, as humans talking to each other, if I don't know, like if someone says something to you, like, oh, for example, I don't need, if I don't remember the sentence, the word, for example, you help me to remember because you know it, and here it goes. So it happens mainly because, one, we know semantics, we know grammar, we know the words, but two, because we know the context, we can identify it. And this is a pain when it comes to the traditional text match, because not everything is there. Not everything is right there in the way we expect it to be. So when it comes to understanding the human language, it's really important for it to allow this context knowledge, this semantics understanding too. So is semantic search used instead of traditional text search? Is that it? Not necessarily. They can complement each other. So this is a point here that I like to pause and explain. You can use it all. It depends on your use case. Think of, for example, you knowing the keywords or knowing exactly the words that you're looking for. You don't really need to go with semantic search. You know what you're looking for. You're expecting the user to type exactly something that you're looking for. Or it's not even like a full text. For example, you have options, alternatives, words for the user to click. And here it goes. Of course, semantics not that needed. So it really depends. If you have what you're looking for, if you don't have, if it's a short sentence, if it's not something with a lot of context, if it's not something that it's not expected. For example, a book, you kind of like have it all already. So you already know what to expect, like the possibilities when it comes like to parts of the book. But if it is a social media post, it might be everything. You don't know what to expect. You don't know what the person is going to type. If it is a chatbot, you don't know what the person is going to type. And here it goes. So it really depends. There's no like good and bad. It's more about like when to use each. But the advantage here that I want to share to you is that you can combine both. You can combine traditional and vector search. And this is the good part here, because then you have what we call a hybrid retrieval. So with hybrid retrieval, what you'll be able to do is you get the score from the traditional term-based query, and you'll be able to combine it in just one request. This is the API call, just one request, the KNN result too, which is the vector similarity score. And then, of course, with just one combined result, again, as a search engine, our intention is for you to get the top result, the one that makes sense, the one that your user will say, well, exactly, this is exactly what I'm looking for. Let me pause here and see if there's something. I'll share the slides later on. Exactly. Yeah, NLP to generate the text. I'm not sharing the other part here because there will be slides about it, about NLP, etc. But yes, semantic goes beyond, because when you store this dense vectors, you store a lot of characteristics of data, and this embedding, basically, in order to generate this embedding, you're using NLP. But let me go through the slides because I'll just share how it fits here. So how to generate this text embeddings? This is the point, and this is the answer that one person just said here. You apply a text embedding NLP model. So in order to have these embeddings, these vectors here, you need to have the vector representation. Remember that I shared, like, you have a document, you need the vector representation, and then you will perform the similarity. So the vector search happens, of course, after you having the representation itself. In order to have the representation, you need to generate it. So this is how it works mainly. You can, of course, have two possibilities. One of them is you just insert the vector as is. Well, does it make sense? It makes sense, because if there's, like, if you already have it, if your company is already storing it anyways, you can just store the vectors as is. But if you want to generate it, we have, like, an option for you to insert what we call a query vector builder, and then you put the model ID and the text, the string, basically the sentence, or anyways the thing that you want to look for, to search. And then in one call, you'll be able to, in one request, you will be able to get your result considering it. So two possibilities here. Of course, when it comes to text, you can insert a string directly. You can insert by using the model, or you can insert the vector as is. And to do that, you will import and deploy the text embedding model into Elasticsearch. So you can use a pre-trained model, you can import your own the way you prefer. For those who don't know, there is a website called Hugging Face. So basically, you can just open the website Hugging Face. You can filter for text embedding models, and you will copy the title of this model. And we have something, a Python client for Elastic, and this is how simple the command line is. You will just insert your cluster ID and then the model ID, which is the title of the model, and the task type, which is, in this case, is text embedding. So this is how it will work. And the good part here is that it's one API request. You don't need, like, to, I mean, you can, but you don't need to first get embeddings and then perform the semantic search. You can, in one request, use what I share here, the query vector builder, and then with the model ID and inserting the query string, and it will work. So after importing your model, you get the model ID, you will start, of course, your model, and when you start using it, you can just perform it in one request, which facilitates, because then you don't need to add a lot of steps when you're using it. Yeah, Hugging Face is really cool. But of course, Hugging Face is really cool when you can import a lot of models. You don't need to just stop when it comes to text embedding. Actually, you can also include a segment analysis. You can include entity recognition, question answering, and here goes. It depends on what you want to do. So there's, like, a bunch of models that we support. When it comes to Hugging Face, of course, all of the models are there, but you need to deploy it. So Elasticsearch allows you to deploy it. Even if you want to deploy it and start using, even if it is not, like, to perform vector search, you just want to perform what we call inference, to know, like, the sentiment of a specific sentence, to return, like, this question answering if you are creating a chatbot, things like that. You can do this. So you just go there, you deploy your model, you start your model, you start using it, and then you'll be able to perform all of these different NLP tasks beyond text embedding, but of course, text embedding true. Vector search also allows image similarity search. This is great. This is something that I know like lots of people, students also like to play with it when it comes like to image and understanding like the different features of it and utilizing it for something. So basically what we have also the ability here is for you to also utilize it for image similarity search. As you have vectors, as you can store vectors, and as you can store image as vectors, you can do this. So you have an input, and the results, again, as explained and as a vector concept, will be the ones, the most relevant ones will be the ones closest to the query in the embedding space. So if you think of a wine here, of course, there might be like, anyways, potatoes, etc., like the supermarket, a lot of food. And then when it comes like to this wine, and considering that we are vectorizing this wine, so let's imagine that it's go like to some place here in this embedding space, it will be close to the other wines. So if you are creating e-commerce, for example, and you want to utilize things like that, to not just rely, of course you can rely on the text, but to go beyond like the labels, you can also utilize vector search, the image similarity search more specifically. And then what you can do too is to connect image and text and to have like the best of both worlds. So here what I am doing is we have like the example I'm giving you is Malbec wine from Mendoza. So Mendoza is a city in Argentina. And then we have like different types of wines considering the text, but also the image. So you're looking for the wine, but of course we can combine it with the semantic understanding. So this is really cool because then you can have both words. If you think of, I think Google has a app nowadays that you can put the image and search for something. So it's kind of it. This is something that works really well. And I think we are used to hear OpenAI here and OpenAI there. So OpenAI has something really cool that you can utilize with Elasticsearch. You can import it. You can start using it. So basically, what you can do is OpenAI has something called Clip. Yes, this is something I don't have the link, but it's really, the link is here, but I can like copy and paste right now. But anyways, if you type on Google OpenAI Clip, you'll be able to find it. It's really easy. It's a neural network that it's trained on this pairs, image plus text. So they already have it. They already have something working, and you can just use it and use it for your use case. Once you deploy it, you can start using it. Yeah, the Clip links right there. Well, you already have vectors, so it allows you to search any unstructured data. When it comes to audio, to songs, another possibility for you to use vectors. So you can transform everything, transform your documents, your PDFs, your images, sensors, all of it into vectors. And then once you have it, you can perform the nearest neighbor search to get your results. So one side you have the query, it might be a text. Of course, if it is text, it will be like the string with the model to convert it, like to convert it into an embedding text, the embedding of the text. And then by having the representation, we will perform the nearest neighbor by running the vector search considering it. Or if you don't have the text, if it's not a text field, for example, if it's an image, you have, of course, directly the embedding of this image, and then you perform the nearest neighbor directly to get your results. Vector search powers the next generation of search, basically. So from semantic search to vector search, utilizing NLP models beyond the text embedding, image similarity, And as I said, lots of possibilities it opens when it comes to video, audio, image, sensors, and all of it. So now I will open for questions, and then I'll show a demo for you that was deployed using Elasticsearch, just for you to see how it looks like. The type of nearest neighbor algorithm. Well, the point is we have like the exact nearest neighbor. You can like choose like the kind of nearest neighbor search that we're going to perform, if it is exact or not. But when it comes, I don't know if we're talking about like how to generate the embeddings. So this is like one step before, which is it's up to you. Like if it comes to like text, for example, you choose like the embedding model that you want to use. To image too, so you have flexibility on this. And when it comes to performing the KNN search, to use search between what we call it ANN or KNN, which are the two options we have available. Let's see. I see that there is a question. Yeah, there was a question before on how to vectorize image. There is a lot. If you put it, literally type it on Google, you see like this. There's like this clip one for like pairs of image and text, but there are simple things like simple libraries that you can use for feature extraction when it comes to image, that you can just utilize one of them and store your vectors. Of course, the quality of your results, it will vary depending on the quality of the models you're using. So this is really important. If it's not that good, it's probably because the model is not that good or the quality of data is not that good. So this is something that you need to take into account when you are choosing on the type of algorithm that you're going to use, the type of model that you're going to use. Well, the mask thing I just explained, basically this is something that utilizes more of like in concept, like when we are like learning how it works and how this models works. But basically when we are teaching a model, or when they were teaching the model before, the masks helps it to predict what would be there. So there's something called zero shot, for example, where we have, I think I do have a demo here, but basically what it does is by removing a part of the sentence, you're able to teach the model on context, on what should be there. So this is basically the way it looks like, and the way you can and the way it can learn and understand like the context, the semantic, and everything that is part of it. Yes, but there is a BERT model available. I don't remember the name of the model, but let's see, because I think I have it easily here. Let's see. There is, let's see if I have it deployed. There is a model, a BERT model. No, it's not working today. Bad. Let me open Hugging Face. Field mask. this one. Let me see. I think fill mask. This is really cool. This is a good model. You can deploy this into Elasticsearch, for example, and start using. So yes, you can use it. You can use the model directly. So this is basically like Paris is and then we just put mask here. And then when you click compute, we have like capital as the one that makes more sense considering this. So you can put the mask somewhere else too. Let me put capital here. And then put here it is. And then France is here. So this is the fill mask. Yes, exactly. If you feel if you think of like the way it learns, it basically considers like all of this possibilities of like possible words or possible terms that would fit, and then it's used to generate what they call like the model itself, like the fine tune for the model. Yes, exactly. So this is one model. Of course, there are lots of them. This is the fill mask. You can read the next sentence prediction exactly is the one that when the person, I don't remember who, asked about prediction. So it's not like prediction, it is prediction in the end. So this is basically what it does. There let me go to demo. I skip it. Let me go to demo and then show how it works. What do you mean by pinpointing? And when you say text search, you mean, because in the end, when we talk about vector search, we are searching through vectors. So vector search is not like even considering like the words itself as is. So it will basically read like the math, like the numbers itself instead of the words. So it's not reading the words as is, but it's reading the numbers, the vectors, the arrays of vectors. Is there a framework or something which can make? Well, you mean, okay, web search. You mean if there is a framework to what, like to generate the embedding, or? Because the point is, yeah, to generate it. Yeah, okay, cool. Well, there are lots of models. You don't need to, I mean, for example, when it comes to, unfortunately, I don't know why this thing stopped working that I created, but anyways, otherwise I would use it and show you it in Elasticsearch itself for you to see how it works. But let me open it here and show you the text embedding model itself. Where's text embedding here? Where's it? Where's embedding? Embedding. So Yeah, it is. They have lots. Well, here it is. This is a good resource from Hugging Face that you can like read, and they will suggest some models, and then you will like choose the right one. But basically, like this is how it works. You will basically, you won't need to do anything else because the models are already available. So you don't need like to fine tune your model. You don't need to customize your model. The model is like, it is expecting, for example, in the case of a text, it is expecting the text, and then it will provide you the vectors, and that's it. Basically, you don't need to do anything besides consuming it. So it's pretty much done. Like, unless you wanted to create your own, or you want to fine tune, which means like training the model itself, like retraining it. Because when it comes like to NLP, all of these models are pre-trained. Even like the field mask that I showed you, all of these models are already pre-trained. So you don't need to do anything. Like when it comes to sentiment analysis, all of it. So there is no like other step for you to, you don't need to work in ML or with ML or something like this. You will consume it as is. Basically, you don't need to go through these steps. You don't need to go through how they did it, how they were teaching it, or how they were creating it. In the end, it will be just the API call with like the input and the result. And then when it comes to embedding, it will be like the text itself and the embedding being generated, the numbers, where you'll be storing it into Elasticsearch, for example, and proceeding with it from there. So there is no like other step or something else that you need to do. So that's why it's pretty much straightforward. Okay, let's go. Let me show you. Yeah. So this is basically something we did with Elasticsearch. Yes, exactly. You don't need to use the masks. I mean, the point is, all of these concepts, like of masks, of like next prediction mask and things like that, are things that were used to train it. But once you're consuming the models itself, it's pretty much as is. Like, for example, let me start here with sentiment analysis. I will just copy and paste this one. So this is an API call, simple as is. I didn't like the soundtrack from the movie. I'll search here, and then it's negative. This is an API call. It's not working the one that I wanted to show, like all of the models, because it's live, of course, otherwise it would. But let me see if I have one here, just to show you how easy it is. Because it's something, it's really an API request. It's done, it's pre-trained. Like when it comes like to these requests, like to these applicabilities of it, it's someone else already did the job. So you don't need to do this unless you want to do this, unless you want to customize it. Let's see if I have some. Here's Kibana, by the way. Trained models. That's what I have here. Facebook. I don't have the sentiment analysis. Oh, I should show the sentiment analysis. Yeah. I can show you right here. By the way, I will share the link of this blog I wrote, and then you can, let's see if I still have this one. I don't know if I still have this model deployed, but let me test it right now. Hopefully I have it, because I need to deploy the model, so that's why I don't have everything here. Let's see if I have something. Okay, cool. It's here. I have the sentiment model deployed. So basically, the model is there, is deployed, and then I insert the sentence, how I want to use it, and in this case, the prediction, which is joy. So it's an API call here, as you can see. It's pretty much straightforward. You don't need to do anything else when it comes like to these models that are on Hugging Face. Someone else did it before you. It's not that no one is doing it. Someone else did it, so that's why it's open, and you can consume one of these models. If it was not for these things like Hugging Face or for these people to just leave it open, you would need to do this. But someone did it before you, so you don't need to do this right now. Let's see. I hate. I don't know. Let's put movies. Anger. And then the probability here. I just wanted to show you it happening in Kibana, just for you to see it, besides having like a fancy front end, for you to see like how simple it is. It's a post mainly, and you have the results. So going back here, let me show you the similar image. This one's really cool. So I'll choose, let's see if I still have the dog. Yeah, okay, I have a dog here. I put the dog, and what it will be doing right now, it will compare. We have like, we inserted a data set from Unplash. I don't know if you know this data set. So you inserted all of their images here, and now it will compare. It's vectorizing like my dog, the dog I inserted, and then it's comparing, like it's running this image similarity search to return the most relevant result, considering where the vector of my query is compared to the vectors of other images are. And then the closest one will be the ones that are relevant. See it? You can even, if you want to test it, like just put here a link for a image on Google for me, and I can do this on real time. I can just go on Google and just for you to see that it's not biased. I'm not saving the dog here. I'm just I don't know, I put something here. House. Oops, not this. Oops. Anyways, house. And save it. And then I'll do the same here. House. So this one I just got from Google, so it's not biased, as you can see. See how cool, even the format. So this goes beyond labels. Think of like me doing the same thing, just typing house. It wouldn't be like, I mean, I can, of course, write a lot of characteristics, but see how fast it was. And then the fill mask, that one that we were talking about, to predict the next sentence, like the next word. Rain was the one that makes more sense in this case. Well, let me talk about something else, like the last thing here before. Yes, I don't know. Did you see like how, I don't know, that I don't remember it was 30% match. Okay, it was not that perfect anyway. So it's kind of more or less, I would say, but still it's useful. So that's why I said, like, you need to, one, make sure that the model is okay, like it's well trained, or it's a good one. You see that, for example, for fill mask and for sentiment analysis, when you're searching for it on Hugging Face, there are thousands, like literally. You need to just go for it and see the one that makes more sense for you. I like to look for the number of downloads. This is my tip. But you can just see whatever you think that makes sense. But I like to go through this metric because I feel that somehow it's good. But it's up to you, of course. And then you can import this and start using it. I didn't know like it was 30% this. Oh, this one is, yeah, it depends like on what it is. I don't remember the prediction probability for all of it, but it's up to you to see like what makes more sense. You can even filter by, like you can say, well, just show scores if it is more than 70%, because otherwise it will be just a guess. You know what I mean? So you can have like this filters too, because in the end it's an API call, so you can use it with all of the filters and steps and pipelines you think it makes sense. So the last thing I want to share with you, just for us to end here because of the time, is I know you're talking about chat gpt, generative AI and all of it. So one thing that I think is really important about generative AI is for you to be able to avoid the creativity of generative AI. What generative AI does mainly, for those who don't know it, it generates the content. So it generates text, it generates a lot of things based on content that is there, that is out there, the ones that it was trained with. Same thing for this sentiment analysis, for all of it actually, like everything, even like sentiment, everything was built using data, using data sets. Someone else did it before you. So this is what I say, like when you go for Hugging Face and you see the model, someone else did before you. OpenAI put like a lot of data, a lot of data there that you're using with generative models to generate the results. So someone inserted data, like it was not trained from scratch without data. People are using data. So in the end, OpenAI is that good because they did it well, the data and the quality of it, etc. So point is, besides what they do, which is like having these predictions, etc. So beside like the generative thing, like there is a tendency to have like some random text being generated. Sometimes it's not exactly I would say like true, considering the data set, considering the context. So what you can do with Elastic is you can have your data source, like your data stored into Elasticsearch, and then you can use it as a context. So you'll be using OpenAI, the chat API, but instead of OpenAI looking through the open data set and with a lot of data and generating content from there, it will utilize your data as like their resource. So you can have like this cool chat GPT interaction, but with data that you want to rely on, like data that you feel is the right one, instead of like opening it. So a lot of companies are going through this route instead of using as is, because then they can just put their own private data. They can like have control over it. And basically, in the end, what we're saying is OpenAI use as a context just this data that is stored into Elasticsearch, all of this. And then you have like the top results, the most relevant results, and then you just return them. So there is a link for this too, which is OpenAI makes private data elastic. Let me share the link. And you can see how to implement it. So now just share the links and then that's it. This link's really cool, and this link is good too. Share to here. That's it. I am a bit late, 5 minutes late. I hope you enjoy and I hope you could learn something from it. Again, this is my LinkedIn. Feel free to add me there and to send me a message. And this is my email address.
Thank you so much, Priscilla. This was a great session. I think everyone in the chat was really pleased, and thank you so much for sharing all of your knowledge on Elastic. I do want to remind y'all that we do have Elastic challenges up on the website, so make sure you check that out at ghw.mlh.io. And yeah, stick around because Steven is going to be coming up right after this to do his their build hack planner part 1 workshop. So definitely stick around, keep it locked in. And once again, thank you so much, Priscilla. Really great session, and thank you all for joining us. Have a good one, y'all.
Thank you.